Alright, so picking up where we left off, like I said, I know that this can be a little overwhelming. It's a lot going on, but once you kind of learn the notation, it's not that bad, but it'll probably take some time. But I don't know. Like I said, 10.7's got some pretty good examples in there if you're really struggling. But the best thing to do is just keep working more problems. Alright, so on this next problem, to solve for this, hopefully everybody's familiar that you're supposed to multiply by the reciprocal. So we're going to multiply, let me just cross this out, we're going to multiply by negative 4 over 3, basically. So I have to multiply this side by negative 4 over 3. If you want to, you can put the 30 over 1 or however that helps you. So the negative 4's cancel out, the 3's cancel out to where I'm left with an r. But here we have to be careful, because looking back at that rule I wrote up at the top, if you multiply or divide by a negative, the inequality sign flips. So this becomes a less than or equal to. And then right here, the 3 and the 30 reduce like so. And so now we're left with 10 times negative 4, basically over 1, so just negative 40. Okay? So r is all the values less than negative 40 or equal to negative 40. So I'm just going to kind of plot negative 40 right here in the middle. And so numbers smaller than negative 40, I don't know. I'm just going to put negative 100. I could have put whatever I want, just as long as it's smaller than negative 40. And then larger numbers like 0, because 0 is larger than negative numbers, so it's obviously larger than negative 40 is over here. So numbers that are smaller than or equal to negative 40, negative 50 is smaller, negative 60, and all the numbers in between there that we aren't even listing. There's too many of them to list. So all these numbers to the left are going to be less than negative 40. But then the equals to negative 40 means that we're going to cut it off right there at negative 40, but we're going to include negative 40. So we get to include negative 40, because if you were to plug in negative 40 for r, it would be a true statement. We'd get a true result. Now, where's the shaded towards? This is where the negative infinity comes in. You might have heard me refer to that earlier. So negative infinity, all we're saying is all the values just continue to get smaller, smaller, and smaller. So the interval notation on this is going to be from negative infinity up to negative 40, and then we bracket the negative 40. Now, a common mistake is students will switch the order of these two. Okay, you got to be careful. You got to remember that it goes from smallest to largest, okay? So this is, that's why I'm saying that a lot of times it's better to draw the picture first, and then hopefully you can remind yourself, oh, okay, negative infinity, always parentheses with negative and positive infinity, and then it goes all the way up to negative 40. So, it really matches the picture. And so all three of these, once again, they all represent the same thing. They just do it in different ways. The number line's kind of more visual. The interval notation is just kind of a quick way of writing it, and then the inequality up here. So, all right. So let's try 57. So hopefully you notice that we're going to go ahead and multiply both sides by negative 4 to eliminate that negative 4 in the denominator's place. So we're going to multiply the other side by negative 4. Once again, we're going to have to flip that inequality sign. So sometimes I like to do this where I circle it and draw an arrow going down right when I introduce the negative 4, so that I don't get lost in this and be like, oh, okay, these cancel out. I'm left with 2k minus 5. And so that kind of drawing that arrow here kind of reminds me, oh, I've got an extra step here. I need to go ahead and flip this to a less than sign. And then 5 times negative 4 should give us negative 20. And now we need to solve this. So we'll start by adding 5 to both sides. Okay, so that cancels out. So now I'm left with only 2k. Negative 20, but we add 5. That should give us negative 15. And it looks like we're about to get a fraction. And it's not a big deal. I would keep it as a fraction. A lot of times on the homework it'll tell you to put your answer as a fraction. So a lot of times they want us to leave it like this. Okay. So k is all the values less than negative 15 over 2. I mean, and so this is really going to be no different than the previous problem, except that we'll go ahead and plot negative 15 over 2 right here. And once again, this is going to be multiple choice, so you'll have a little help on your number lines. But it's nice to do a rough sketch to help you with the interval notation. And so let's see, k is all the values less than. So the smaller values are to the left. So it's shaded towards negative infinity. And we're going to use a parentheses because of our inequality sign. Our inequality sign right here tells us to use a parentheses because that indicates that negative 15 over 2 is not part of the values of k, the possible values of k. And then that kind of helps you out with the interval notation because it's going to go, you kind of look at your graph from left to right. So negative infinity to negative 15 over 2. And we're going to have parentheses on both of these. And there we go. Okay, so there's another one. All right. So like I said, this is going to be practice, and eventually it'll come second, nature that, okay, this sign, parentheses, this other one is a bracket. Now, this is kind of a trick right here, and you might have noticed this on the first couple examples. As long as you have your variable on the left side, if you have your variable on the left side, your inequality sign kind of tells you which way to shade. If you notice, this is kind of pointing to the left. If you notice, this one's pointing to the left. It looks like this right over here. Kind of, shaded to the left. And if we go back up and look at the previous two examples, if you notice, it's pointing to the right. This one's pointing to the right, and that's the way you're shading. Now, that's kind of a trick, though. I mean, it's better that you actually have a grasp of why you shade one direction or the other, but I just thought I'd point that out. Sometimes that can be helpful, but you have to be careful because the variable has to be on the left side of the sign right here. It has to be on the left side, but that might be something that might be helpful. All right, so let's knock out a couple more. Alright, so here we'll draw the line. We're going to subtract 1 from both sides. That cancels out, and we get 3k is less than negative 21. Next step is to divide by 3. Divide by 3. That cancels out, and we get k is less than negative 7. Now you might be saying, well, wait a second. Aren't you supposed to flip the inequality? You divided, and there's a negative sign there. But you have to be careful. If you look back at the rule, you only flip the sign when you multiply or divide by a negative. And we divide by positive 3, right? 3 is positive. So be careful. That's a common mistake people will make is they'll do the division and what they're dividing is negative, and they'll be like, oh, okay, I got to do my sign. Not in this case. Not on this case, okay? So here we go. K is all the values less than 7, negative 7. So here's negative 7. Okay, all the value, if this is negative 7, all the negative values all the values less than negative 7 are going to be to the left towards negative infinity. And we're going to go ahead and use that parentheses. Ooh. Okay, there we go. And so once again, this gives you a nice picture of how to do your interval notation. You just read this thing from left to right. Negative infinity to negative 7. Always parentheses with infinity or negative infinity. And then with the negative 7 parentheses. There you go. All right, let's look at 61. It's not really as bad as it looks. It's, you got to distribute here. So let's see, x plus 8x minus 4 is greater than or equal to x. We'll go ahead and combine these. So we get 9x minus 4 greater than or equal to x. Okay, got to isolate the variable to one side, so I'm going to subtract an x off of each side. So it leaves us with 8x minus 4 is greater than or equal to x minus x. That's you know, like saying 5 minus 5, which is just, it's just 0. X minus x is just 0. Okay, so then let's see, we got to isolate the variable. So we add 4, so we get 8x is greater than or equal to 4. So now the variable is isolated over here. Completely isolated by dividing by 8. That cancels out, and we get x is greater than or equal to 1/2. And once again, don't freak out with the fractions. Not a big deal. X is all the values larger than 1/2. We'll put 1/2 here. Larger values are to the right, like 1, 2, 3, you know, even, you know, 1.5, 3.47, whatever. All those numbers are larger than 1/2, and it's going towards infinity. The inequality sign here is saying that we can include 1/2, and so that's what the bracket means. The bracket just means, okay, you can include that value. Now we read it from left to right. 1/2 to infinity, which means starting at 1/2, including it, and all the numbers larger. There we go, done. So all these represent the same thing right here. All three of those represent the same thing. Okay, let's see what we got going on next. Okay, I'm going to try to knock out one or two of these. We'll see. It looks like there might have to be a third video on these inequalities because it's not something I want to rush through. Alright, so if you want to draw that line, so we're going to distribute the negative. So we're going to have negative 4 minus r. Now this stays plus 2. The negative, you know, doesn't get applied to, it only applies to whatever's inside the parentheses. Now it's time to clean up the left side. Let's see what we have in common here. Alright, we've got negative 4 and positive 2. That will give you negative 2. We've got minus r and minus 3r together combined to give you minus 4r is less than negative 14. It's time to isolate the variable by adding 2 to both sides. That cancels out, so we got negative 4r is less than negative 12. Going to divide by negative 4, and so I'm going to go ahead and circle that and draw a line to remind myself that that's going to switch because I'm dividing by a negative this time. That cancels out. R is greater than 3. Okay. And so now we need to draw a number line representing that. So we put 3 right here in the middle. So we'll shade to the right where we have our larger values. And we're going to use a parentheses because of the inequality sign. And then it's from 3 to infinity. Alright, so on 65 we distribute the negative 3. Negative 3z plus 18, and then we got the greater than 2z minus 2. Alright, so you might want to draw that line. You don't have to. And so since we've had the z on the left side the whole time, and I kind of told you about that trick about how you kind of shade the way it's pointing, the variable has to be on the left side, so maybe we should just I should stay with that pattern in case you're going to kind of use that as to assist you on these problems. So here we go, cross that out, so we get negative 5z plus 18 is greater than negative 2. And then we're going to subtract 18 from both sides. So negative 5z is greater than negative 20. And then next we're going to divide by negative 5. Oh, circle it to kind of remind yourself that there's going to be a flipped. You're going to flip that there. So it becomes less than 4. Plot 4. Z is all the values less than 4. You can see it's pointing to the left. Like I said, it's kind of a trick, but you know, if it kind of helps you get through this section, you know it is what it is. Then we use a parentheses, and it's from negative infinity to 4. All right, one more video.